Across global oceans, a new breed of 400-meter megaships is carrying $1 billion in cargo without a single human crew member on board. Driven by artificial intelligence and satellite navigation, these autonomous titans are transforming 90% of global trade. The traditional wheelhouse is completely deserted, replaced by autonomous neural networks that never fatigue or lose focus. Stacked 24 containers wide, a single voyage holds over 20,000 containers valued at more than $1 billion.
Eliminating human living quarters frees up thousands of cubic meters of deck space for additional high-value cargo. Without mess halls, cabins, or lifeboats, the hull architecture is streamlined for maximum aerodynamic efficiency. While crewed vessels face labor shortages and human error, uncrewed titans operate continuously with mathematical precision. Every square meter of the vessel is monitored by multispectral optical cameras, infrared scanners, and spinning LiDAR domes. Automated ballast control systems dynamically adjust water tanks to maintain perfect stability regardless of sea conditions. Powered by green ammonia and electric propulsion, these vessels eliminate thousands of tons of carbon emissions. Shore-based captains supervise dozens of autonomous ships simultaneously from high-tech control hubs thousands of miles away. Phase 1. How AI navigation and sensor fusion replace human eyes and ears on the high seas. At the core of the ship's navigation is a multispectral sensor rig that sweeps 360 degrees every second. Millimeter wave radar pierces through blinding ocean fog, heavy rain, and pitch-black darkness with absolute clarity. Sensor fusion algorithms combine millions of data points, building a 3D digital point cloud of the ocean environment. While crewed vessels face labor shortages and human error, uncrewed titans operate continuously with mathematical precision. Onboard quantum-grade processors analyze wave frequencies and wind resistance to adjust rudder angles in milliseconds. Triple redundant satellite connections lock the ship's position down to 2 centimeters anywhere on Earth.
Dynamic fin stabilizers deploy automatically under the hull, reducing vessel roll and protecting fragile cargo.
Hull pressure sensors monitor structural flexing, slowing engine output automatically when confronting massive storm waves. Deep learning algorithms process global weather forecasts, altering ocean routes to bypass dangerous typhoons completely. At the core of the ship's navigation is a multispectral sensor rig that sweeps 360 degrees every second.
Inter-vessel communication channels allow ships to negotiate passing maneuvers autonomously across miles of open sea.
Sensor fusion algorithms combine millions of data points, building a 3D digital point cloud of the ocean environment. Inside the engine bay, 0 human engineers are present. The entire propulsion plant is 100% automated. Massive dual-fuel engines burn green ammonia, backed by predictive AI diagnostic sensors monitoring every piston.
Direct-drive permanent magnet electric motors deliver 100,000 horsepower straight to the giant propeller shaft.
Self-regulating lubrication pumps and automated fluid exchangers replace manual routine maintenance entirely. Magnetic crawling robots traverse internal steel bulkheads, scanning welds for stress fractures using ultrasound.
If thermal sensors detect smoke inside a cargo container, automated Novec gas systems flood the hold instantly.
Thousands of refrigerated containers holding perishable food and pharmaceuticals are monitored wirelessly round the clock.
Automated lashing locks monitor tension on container stacks, adjusting steel cables dynamically to prevent deck collapses.
Internal sensors track humidity and vibration levels inside high-value cargo containers containing advanced semiconductors.
Modular mechanical systems allow onboard robotic arms to swap worn hydraulic valves and filters during transit.
Zero-emission power generation ensures these billion-dollar giants comply with the strictest environmental regulations.
Phase 3 complete. Now see how uncrewed megaships dock and unload without human dock workers.
As the vessel reaches port, human harbor pilots are unnecessary. The ship communicates directly with port AI.
Precision laser sensors guide side thrusters, gliding the 220,000-ton ship toward the dock wall with millimeter accuracy.
Automated vacuum mooring pads extend from the quay wall, clamping onto the steel hull in less than 30 seconds.
Eliminating traditional mooring ropes speeds up berthing operations while eliminating one of shipping's most dangerous jobs. Colossal automated quay cranes lower spreader beams onto container roofs without a single operator in the cab.
3D optical cameras and alignment systems allow cranes to lift 40-ton containers every 45 seconds.
Driverless electric shuttle vehicles receive containers, navigating along transponder grids embedded in the concrete. Port logistics software sorts and stacks $1 billion in cargo based on destination priority and weight. High-speed X-ray portals inspect container seals and cargo manifests automatically as vehicles pass through. Robotic arms extend shore power cables to the ship's side, powering onboard systems with green grid electricity. Automated battery exchange stations swap depleted shuttle packs in under 2 minutes, maintaining non-stop port throughput. Phase 4 complete. Now see how cybersecurity and anti-piracy defenses protect these uncrewed billion-dollar assets. Without human crew to hold hostage, uncrewed megaships present an unappealing target for ocean pirates. Retractable electric barriers, acoustic deterrence devices, and high-pressure water cannons defeat unauthorized boarding attempts. To prevent hacking, quantum-encrypted satellite links isolate navigation networks from external network intrusion. If communications fail, onboard offline AI protocols continue navigating safely along pre-approved oceanic corridors.
Turnaround times at automated ports are cut in half, maximizing vessel utilization and reducing port congestion.
High-tech shore jobs replace dangerous sea deployments, allowing maritime operators to work standard office hours.
Operational costs drop by 30%, translating into lower freight rates for consumer goods worldwide.
By 2030, thousands of autonomous megaships will form the backbone of a zero-carbon global supply chain.
International maritime organizations are establishing universal regulations to govern uncrewed international shipping lanes. A monumental fusion of robotics, artificial intelligence, and naval engineering, moving the global economy. Proof that human ingenuity can automate the largest machines on Earth to sail seamlessly across the planet.